Hi, I'm Granny, and we're going down the rabbit hole of the moon and our universe. So, last time we talked about exosphere and atmosphere and what the difference is. Well, in our solar system, there are two objects that I found that have what is referred to as an exosphere: our moon and Mercury. An exosphere is a thin atmosphere like volume surrounding a planet or a natural satellite, which is what our moon is, where molecules are gravitationally bound to that body. Because the exosphere's low gravity and pressure, some of the exosphere makes it into outer space. Solar wind, and we've talked about that before, storms from our sun compressing the exosphere, like on Mercury, causing pressure to build up and also release molecules out into our universe. So, to understand our universe, scientists use spectroscopy, and we've talked about, excuse me, we talked about spectroscopy previously on how it is used by scientists. So, in this scenario, scientists use spectroscopy to see what colors are emitted or absorbed and the relative amounts of each wavelength, which we discussed before in the light spectrum, that astronomers can identify the chemical composition of a planet or star and its atmosphere, and interstellar nebula, along with the temperature and pressure of the gas. Astronomers use known spectra that we're aware of to measure the distance to galaxies. Almost everything we know about the makeup, temperature, and motion of planets, stars, and galaxies comes from spectroscopy, which is really interesting to me. So, we're going to talk about our solar system. We have 8 planets, and the 4 closest to our sun are called terrestrial planets, are composed of solid surfaces: Mercury, Venus, Earth, and Mars. We'll start with Mercury, the closest to the sun. Mercury has 0 moons. It has an exosphere, probably because its location closest to the sun. Its exosphere is mostly hydrogen, helium, sodium, oxygen, and potassium. And that is very similar to our planet. Its crust and core is solid silicate, maybe with an iron core. Is the most cratered planet, which it's slightly larger than our moon, and it's the second densest in our solar system. The temperature range on Mercury, daytime it's around 800 degrees, and at nighttime it's around minus 290. It takes 88 days to orbit around the sun, and its day is composed of 58 Earth days. Anyway, the next is Venus, and it has 0 moons. Its atmosphere is mostly carbon dioxide and sulfur. Probably doesn't smell very good. Its crust and core is believed to be high ferrous iron ratios. Calcite and dolomite is believed to be at one time covered in liquid water oceans. Currently, it is covered with volcanoes and is considered the hottest planet in our solar system. The average temperature is 900 degrees. It takes 225 days for it to orbit around the sun, and one day is 243 Earth days. Next comes Earth, and it has one moon, which we've learned about and so grateful for. Its atmosphere is mostly nitrogen, oxygen, and argon. Its crust and core is mostly iron, calcium, silicon, aluminum, sodium, potassium, magnesium. Earth's atmosphere has remained stable because of our moon for billions of years, allowing complex life like you and me to develop. And that life here on Earth is what helps maintain our atmosphere. And Earth is the densest planet in our solar system. Temperatures range from 134 degrees to minus 89.2, and you can go down that rabbit hole. It takes 365 days to orbit the sun, and one of our Earth days is 24 hours. Next is Mars. It has two moons. Its atmosphere is mostly, like Earth, carbon dioxide, nitrogen, argon. Its crust and core is mostly iron, nickel, magnesium, aluminum, calcium, and potassium. Get this. Mars is approximately half the size of Earth. NASA sent MRO, Mars Reconnaissance Orbiter, to Mars to study the feasibility of a settlement. The MRO has orbited Mars over 60,000 times. Some of the information the MRO has sent us, or to the scientists, is it used to have a magnetic field. In its infancy, had the same ingredients for life as Earth had, such as hydrothermal vents. According to geologic evidence, was volcanically active, which then caused huge floods, including the solar system's largest known waterfall. The water, because of the geologic evidence, was because of the volcanic activity, it caused huge floods that, again, according to geologic evidence, poured into a particular canyon that was 10 kilometers wide and 100 kilometers long, and then the water disappeared. Now, it makes me think, remember when we were looking at volcanoes and how Japanese scientists determined that 90% about more water was in the mantle of the Earth than on the surface? It kind of makes me wonder, geologically speaking, there was evidence of that huge waterfall, and could that canyon have essentially helped all that water go down into its mantle? The water disappeared, according to the scientists, and 3.7 billion years ago, it started to become colder, and what water there is has migrated to its poles. The temperature on Mars ranges from 70 degrees to minus 80 degrees. It takes 687 days to orbit the sun, and one day is 24.6 hours. The next 4 planets in our solar system are called Jovian or gas giants, and composed mostly of gases and ice, and is believed to have no solid surface, which is a very big curiosity to me. So Jupiter has 80 moons. Its atmosphere is hydrogen, ammonium, sulfur, methane, and water, and whatever kind of core or crust there is. It could include iron and silicate, a storm on the surface of Jupiter has been raging and noticed by scientists or astronomers for hundreds of years. The storm is 2 times the size of Earth, with wind speeds of 270 miles per hour. The temperature range on Jupiter is 1,340 degrees at its surface to upwards parts of its atmosphere of -50. It takes 12 years to rotate around the sun or orbit, and one day is 10 Earth hours. Next is Saturn. It has 62 moons. The atmosphere is mostly hydrogen, helium, methane, and water, and the core or crust is believed to be mostly iron and nickel, and could be solid, but it's hard to tell because the atmosphere is so thick that it's hard to determine. Titan, its largest moon, is 2 times the size of our moon. Saturn is almost 3 times the size of Earth, has 3 layers of clouds in its atmosphere. And imagine this, the atmosphere is 50 times denser than the Earth's. It's believed that the surface lakes are made of methane, and the Cassini space probe was a sophisticated robotic spacecraft, and it was sent to Saturn and its complete complex ring systems and moons, and it discovered the lightning on Saturn was 10,000 times stronger than Earth. So imagine this atmosphere as dense as it is, and many times stronger than these. Imagine if you've ever watched those crafts that go down into the bottom of our ocean. Well, according to Cassini, that the atmospheric pressure at the bottom of our oceans compared to the atmosphere on Saturn is 80 times stronger. Because of this pressure, the lightning in the atmosphere transforms the methane gas into enormous clouds of graphite rain. And because of the enormous atmospheric pressure, this rain is changed into diamonds that rain down onto the surface that then are destroyed because of the pressure, because of the surface pressure. And on the crust of Saturn, it is believed that the pressure is so high that the helium liquefies, creating electricity, so that the molten helium merges with other chemicals in the atmosphere, which is what they believe fuels Saturn's weather. It's these chemical reactions that take place that are similar to what we see on the surface of the sun. These chemicals creating and interchanging and reacting to each other is essentially what fuels it, kickstarts each other, in other words. The temperature ranges from 134 degrees to minus 113 degrees. It takes 29 years for Saturn to orbit the sun, and 1 day is 11 Earth hours. Next is Uranus. It has, get it, 27 moons. Its atmosphere is mostly hydrogen, helium, methane, and according to scientists, because of the chemicals in the atmosphere interact with each other, but mostly it's the methane that gives Uranus its greenish color. The crust or core, they believe, is mostly rocky, covered with water and ammonium and methane. It rotates on its side, so you'll see the ring that is surrounding it, similar to Saturn, is on its side, not this way. Uranus rotates this way. And there's theories that go along with why it does that. But anyway, temperature range from its atmosphere, outer atmosphere, to the inner atmosphere, layers of the atmosphere, range from minus 370 to 116 degrees. It takes 48 years to orbit around the sun, and its day is composed of 17 Earth hours. Next comes Neptune. It has 14 moons. Its atmosphere is mostly hydrogen, helium, and methane. And again, the scientists say because of the composition of each of those chemicals is what gives Neptune its rich blue color, different than Uranus's green color. And they describe that the core, or whatever is composed of the core, is mostly iron, nickel, and silicates. And get this, the highest recording winds in our solar system is on Neptune, and they are recorded at 1,500 miles per hour. Wow. Its temperature ranges from minus 328 to minus 360. It takes 163 years for it to orbit the sun, and 1 day is 16 Earth hours. And just because I like Pluto, and anyway, it has 5 moons. It's considered not a planet, but a dwarf planet. Its atmosphere is mostly molecular nitrogen, methane, and carbon monoxide. The crust/core is thought to be made of mostly ice. It probably has a rocky core, which might contain some metals, but we don't know. The ice on the surface of Pluto is made of frozen nitrogen, methane, and carbon monoxide. The temperature range is from minus 369 to minus 387. It depends on your sources. And 1 day is composed of 6.5 Earth days. Now, as a reminder, these bits of information that we have about the other planets in our solar system, depending upon the source, changes slightly from one source to another. And so when I give you temperature ranges and the orbits and hours of one rotation or day, it really depends on the sources. And so I kind of try to average it each. I just don't want you to, just know that everybody has an opinion, and that includes scientists. Anyway, I want you to check out NASA's James Webb Space Telescope. It's known by JWST. And according to NASA, there are more than 3,916 known solar systems in our Milky Way. And again, according to JWST and the scientists studying the data, There are 5,241 confirmed exoplanets. Exoplanets are planets that exist outside of our solar system. That information has updated other information because of the clarity of that telescope and the information that has been sent back. And when I went down the rabbit hole of stars, I kind of noted or reminded you of all of those different changes that are taking place with information. So please join me next time as Granny goes down another rabbit hole. Please like and share, and thank you for joining me on my adventures.